India missed the bus on a few technologies. Start now, replace as machines get better, and that's the way we look at quantum. We believe that photonics is the technology which will scale the fastest.
Welcome to the Build for India series. This episode being the quantum value, who's already using it, what it means to run two very different product timelines inside one company. And for the episode, we have Sujoy with us. Welcome, Sujoy.
Hi, thank you. Thank you, Shreya.
Most quantum companies ask enterprises to wait, but you guys didn't. What made you take this bet?
Yeah, so a lot of people think that quantum is this magic pill, right? A 0 to 1 journey, that something will come and then the whole world will change. What we realized very quickly is that how things will evolve. And there's a lot of other work needs to be done. There's a lot of understanding the problem, framing the problem in particular ways, running some algorithms on it. And then what we said is, you go incrementally. Use what you have today. Use quantum inspired, use the near-term quantum machines, and start solving pieces of it. And so the problem statement remains, the problem remains solved, and you're just going to keep pieces as the machines get better and better. So that's how you get started today, and then go into the future, replace the specific parts, and have a full solution. So start now, replace as machines get better, and that's the way we look at quantum.
Great. So when you say optimization problems, logistic, finance, material, what does a real deployment actually look like for a customer? Can you talk a little bit about that?
Sure. So, quantum computers are capable of doing is solving optimization problems. So, when you look at it the first time, you say, what's the big deal? Well, the big deal is that optimization problems are a class of problems which is NP hard, right? So, as the number of variables you want to optimize increases, this quickly overwhelms all classical systems. So how do people do it today? A lot of people do it by either breaking the problem down into smaller pieces, running the problem for a very, very long time,
Okay.
or the most conventional way that people do it is from experience. Oh, there are these 60-year-old people sitting there saying, I have done this for 40 years. I know that this is the right way of doing things, right? This is the right way of shipping things out. This is the right way of buying something at an auction, and so on and so forth.
Yeah.
Right? And the reason for that is just that because at a certain point of time, computers can no longer efficiently solve these problems. So when or a machine like ours comes in, right? So we are not classical. We don't go explore the solution space one by one and start competing with GPUs and CPUs and stuff like that out there. What we do is we use the physics of this all, right? And there are physical properties, which is why it's called quantum inspired or quantum like, right? I mean, the physical properties of if you every variable as a spin and you have some interconnection with them, etc., you can set up an energy function. And that energy function is then physically solved. It's solved the way physics would. It evolves with time and so on and so forth. So this gives you solutions, and this gives you very good solutions to very large problems. And sometimes it gives you surprising solutions. And people realize that if they use this, they end up saving money, saving time, saving resources, which is a big deal given today's world.
Yeah.
So that's why this method inspired or quantum like method to start with, and eventually quantum computers will come in and these methods will become quantum, they'll become faster, they'll become more predictable, and so on.
Thank you so much for answering that. Let's go a little bit, let's talk a little bit about, Quanfluence. Now, your photonic approach differs from the superconducting system. I'd like to know why did you choose this and what it does, what others cannot do. So why this and how is it different?
Yeah, I think at this point you're talking about our quantum computer itself, right? The grand product.
Yes.
And that's the one where we decided to go the photonic route. There are quantum computers out there. They're not powerful enough. They're not big enough. They are still quantum. They can solve some problems, but problems, right? And these technologies are basically the superconducting, the ion trap, those kind of technologies, which are at about 1,000 qubits. And I think if you go ask people out there, everyone will tell you that you need 100,000 to be a really usable machine. And I haven't seen how these systems go from 1,000 to 100,000. I mean, I'm sure that people are working on it. Some very smart people are working on it, but we couldn't see that
Okay.
path forward. And that's where we thought, is there another approach? And it was not just us, there are other people in the world also thinking, is there another approach? And that another approach happens to be photonics. I mean, there are people who are doing some other materials and stuff like that also, but there are a lot of people in the world who
Yeah.
believe in photonics. And that's where, the photonic way of computing came about. And, you say that our qubits are always in motion and so on. The jury is out. Nobody's built a large enough photonic computer out in the world. The biggest computers are still the superconducting and the ion traps. But we believe that photonic computers will come into their own and scale rapidly and leapfrog these existing machines. So that's why photonics.
And how
And
hard is
as a
that?
company, we also decided that we will not copy someone's technology or do it like someone else. So we had a greenfield approach, we did some pretty fundamental work around it. And our method of doing photonics is also very different from what a lot of the other people in the world are doing. And we believe that this is the right approach to building that scalable machine.
I have a follow-up on that. You said nobody has built it yet, but how you're working in this space, and I'm sure you have a much better understanding about it than people who are just giving verdicts. Are we really from seeing photonic become mainstream?
Yeah. When I say nobody has built it yet, please don't misquote me. What I meant is nobody's built 100,000 qubit machine yet, right? Which
Okay.
would be the game changer. People do have small photonic machines, and that's very encouraging. How far are we from this being mainstream? I think uh, I believe that from any quantum computers being mainstream, we are probably 3 or 4 years away, if not longer. So it will take time, but when it does, we believe that photonics is the technology which will scale the fastest.
Great. I know that following Confluence's journey for a long for a while now, right? So, and I am aware that you do have some paying customers as well. I'm not going to give any number here, but let's just say that you have good number of customers. I want to ask you what was the journey like when you were, when you had started approaching them, and then what them to get comfortable with you, and could you share some timelines? What was this journey like for you?
Yeah, sure. So we do have some paying customers. And it is very interesting. Okay. Human beings, I mean, when we were growing up, or when human beings are growing up, we think that computers are these perfect machines, right? That, if you ask a computer 2 plus 2, it'll always say 4. Right?
Yeah,
And
but
then that's what your mentality is or mind frame is, and so on and so forth. And then we come out here and say, I'm pitching you this machine. It's extremely fast. It can solve really large problems, but sometimes it doesn't give you the best answer. And that is a very, very hard thing for the human mind to process, right? So I'll give you an example. Our machine can solve Sudoku,
okay.
right? So if you go to a computer, right, your laptop, and you try solving a standard Sudoku on it, it solves it in a second, like not in a blink of an eye, because you can try all of those combinations and solve it, right? So then you increase the Sudoku grid, you make it a larger grid, right? Eventually, you go to an 81 by 81 grid. You give all the compute power in the world, and it won't solve. And that's how rapidly these problems expand. What
Interesting.
our machine does, right, when you try to solve Sudoku, that if you give it a 9 cross 9 grid, it takes a couple of seconds, and you're like, oh, this is not great. Give it a bigger grid, it takes a few more seconds, and you say, okay, this is pretty fast. You give it a huge grid, and it still gives you a solution. It probably takes 2, 3, 5 minutes, and it gives you a solution. So, oh, wow, it's giving a solution, right? The problem is sometimes it gives you the wrong solution. It gives you almost right solution. So if you're trying to build a Sudoku solver, we are not the right approach. But these problems that we are talking of, these logistics problems, these finance problems, these optimization problems that you're talking of, you do not necessarily need to get the best solution. You need to get a solution which is better than what you would have got if you didn't use a computer. And that, I think, was the conflict which we had to overcome with customers, getting the customers' mindset from saying that, you don't need an exact solver. You need a solver which does better than what you can do. And
Okay.
once that happened, I think one of our first customers was trying to solve an auction problem. So they were doing it using standard software by splitting the problem down, etc., etc. And they were getting exact solutions to split problems. What they realized is that if they didn't split the problem and solved the whole thing, even though we were not an exact solver, they were getting a better solution. So they were saving, time, energy, money. They were being able to place better bets, though we are not a perfect solver. I think that is the transition which took time and which was that game changer.
Got it. So I know and there's a follow-up on this question only. Tell me a little bit more about what apart from this convincing, what do you feel is the bigger barrier to adoption of such technology, such as yourself? Is it market readiness, or is it the awareness? What exactly you've learned and understood in your journey so far?
Yeah, I think for me, what I think the biggest barrier is, who will write the software around this? So we have a machine, it does fantastic things, right? But it doesn't do fantastic things by a natural language prompt today. So
Okay.
I can't do a natural language prompt and get it, which you can basically do with other software today easily. And today, when I tell a guy to write software, he goes to the software tools, writes a few prompts, gets a beautiful thing and runs it. Everyone knows how these things run. Everyone knows that the answers are believable, and you move on. Right? Here, what happens is someone needs to write the software. What the software needs to do is it needs to take your problem and convert it to something that can be loaded on this machine. And then when the answer comes back, the software needs to reinterpret it. And I think what's going to happen very soon is that, people are going to write open source software for doing this, and AI models are going to get better at doing this and so on. And
Yes.
then it will become mainstream. So I think right
Got
now
it.
the issue is that, it's not that mainstream. And I think that'll happen soon.
Got it. Understood. I think the time has really flown, talking to you, but I do have one last question for you. India is in the middle of one of its most ambitious technology bets in era. And if quantum succeeds here, what does it change? Not just for the industry, but for what India truly believes in, what it is capable of building.
Yeah. See, I think India missed the bus on a few technologies. And on a few technologies, we actually didn't. We did pretty well for ourselves on space and nuclear and stuff like that, right? But all of this was kind of government driven. And then, when private players started coming in, what we realized is that some of the technology buses we missed, the entire semiconductor revolution, uh, even AI, I would say. So, what I see as promising is that, quantum was picked up pretty early, and private enterprise was also encouraged to get in there and start building quantum and so on. uh, this is a technology which is fairly strategic. uh,
Mhm.
it is going to be very, very needed for India and for the world.
Mhm.
And I think, we started early enough, we're putting enough focus on it. There is funding out there to make sure that, India becomes one of the top players in this, provides this tech, not just for us, but for the whole world. So I think that would be a game changer. And this is hopefully a bus that we don't miss. And very soon the world should take notice of the fact that, hardcore technology is coming out of this country.
Okay, so here we come at the end of the conversation. So, Joy, just to wrap this up, what's the one piece of advice you would give to innovators and entrepreneurs who are starting their journey in quantum today?
Yeah, I think my advice is fairly simple, that, building quantum is hard. Building any enterprise is hard, but, quantum can sometimes get extremely confusing, extremely difficult, but stick to it. And I think that's most necessary. Stick to it. Eventually, when things are measured, they all collapse to the right values. That's how quantum works. And by that, what I mean is that things will follow, money will follow. There is equity participation out there from VCs, and we will build something great in quantum together. So just stick with it, build technology.
Thank you so much, Sujoy. It was wonderful chatting with you. I appreciate you joining us.
Thanks, Shreya. It was a pleasure.